This is Algebra 2 with trig. This is Unit 1, C.3. This is the operations of complex numbers. So when we're trying to work with quadratics that don't have a real solution, we usually have to take the square root of a negative number, and we find out that that doesn't work. Well, we're going to come up with what's called an imaginary number that's going to allow us not to run into a brick wall. We're going to be able to come up with a solution. This imaginary number is going to represent the square root of negative 1. So when you square a square root of negative 1, you get the value that's inside. So I squared always equals negative 1. Remember that. I squared, whenever you have I squared, you have to substitute a negative 1 in for it. So what we're talking about is when you're doing the square root of a number, we're no longer going to leave the negative inside the radical. We're going to pull it out and we're going to call it I. We don't call it negative square root of r, we call it I square root of r. For example, if we have the square root of negative 3, we call it I root 3. That's called an I for imaginary number. So this imaginary number times root 3. It doesn't exist on the number line, but in the world of math, we're going to consider that good enough. So then we're going to notice here that when we square I square root of r, we're going to square the I, which is squaring the square root of negative 1, which gives us a negative. And when you square a square root, you get what's inside, so now we get the negative r when you square that. For example, if you're squaring, you're going to square the I, which gives you negative 1. That's what we said earlier. I squared gives you negative 1. Square the I, times the square root of 3 squared, which is 3. So you get negative 3 as an answer. So these would be all answers that we would usually say we couldn't solve. But now in Algebra 2, we will be able to solve them. We're trying to take the square root of a negative number. Usually it's no solution. But now, when we take the square root of both sides, we still get plus or minus, and we're going to get this I square root 13 as our solution for x. When you take the square root of a negative number, we no longer have the negative floating around. We say I square root of 13. We use the plus or minus now because we're taking the square root of both sides. Subtract the 18. So that comes out to be negative 90. Divide that by 2. That's negative 45. Well, we can take the square root of that. Now what? X equals plus or minus, because we're working with equations and taking the square root of both sides, I square root 45. Well, the square root of 45, yes, you're right, can be broken down into 9 times 5. So you know that that is, we usually write the number in front of the letter, so it's 3i plus or minus 3i root 5. So we took the square root of both sides. It had a negative in it, so we pulled the negative out using the I. That's the square root of negative 1 being pulled out. And then we broke the square root of 45 down into 9 times 5, so that's really 3 root 5. So it's 3i root 5. Subtract the 33 to the other side. That gives us our negative value. We can still divide by a 5. We've always divided and had no troubles in the past dividing a negative number by a positive. But when we take the square root, we're going to get plus or minus. Because we have that negative 6 being square rooted, we're going to use I instead. Put the 6 in there. It's inside this square root. Can 6 be broken down? 2 times 3. But there's no pair of the same number. There's no perfect square. So we leave it as plus or minus I root 6. Well, when we took the square root of both sides, we no longer had that squared. Did you catch that? Or are you just sitting there copying it? Pay attention. Okay, a complex number is any number that can be written into the form. This is called a complex number. It could be plus or minus bi. A plus or minus bi. Where the A is considered the real number. Little hashtag standing for number. And the bi is considered the imaginary number. So that's called a complex number. Well, we're going to do a couple different things with complex numbers. We're going to add and subtract them, then we're going to do some multiplying. But here, one of the biggest mistakes, I can't say this enough, people are going to do it. You're going to FOIL when you're not supposed to. Just because you see parentheses, you're going to think FOIL and you start to do craziness. It's a plus. So if it's a plus, we do not need the parentheses. We have a negative 8. So maybe we want to use parentheses with that because we're adding a negative. But we don't need all those extra parentheses. This is not a FOILing question. So 12 and negative 8, those are your like terms. So that gives us 4. Negative 11i and positive 3i, those are your like terms. So we get negative 8i. We don't need to worry about factoring any terms out here. That is your final answer. You simplified what was written there. You had this complex number plus that complex number. When we add them together, the real numbers add to 4. The imaginary numbers add to negative 8i. Done. What do we do here? Here we have the negative. Here we need the parentheses because that's telling us to distribute that. So we have 15 minus 9i. I needed the parentheses so I knew I distributed correctly. But I no longer need the parentheses because I've already distributed my negative. You have to have a plus 9i there because two negatives make a positive. So you have a positive 15 and a negative 24. Those are your like terms. So we're going to get 9 with our like terms. Here we're going to get 0 actually. Negative 9i and a plus 9i. That leaves us just with 9. When it's possible, remember, we want to leave our answers as A plus BI. We don't want to put the I value first. We want to always put the I value last. It's just notation. Okay, what can we do here with this example? Well, we can distribute our negative through. Then you no longer need parentheses. And where are your like terms? Your like terms are here. So 35 minus 13 is 22. Negative 4 and a positive 9, those are both I, so that's a positive 5I. On the flip side, we're looking at multiplying complex numbers. Remember what we've talked about. Be sure that whenever you see I squared, that you turn it into a negative 1. So notice here, there is no plus in between the terms. That's when you know you multiply. Distribute like usual. 5 times 8 is negative 40 times I. A negative and a negative makes a positive. A 5 times a 4 makes 45. And the I times an I makes I squared. That's what we mean by we have to convert the I squared into a negative 1. So negative 1 times 45 is negative 45. And then you always write the I term at the end. You want to write the real number followed by the imaginary number. Here there's no plus or minus in between the parentheses, so this means multiplication. So negative 8 times a negative 7 is positive 56I. Positive 8I. Negative 14I squared. Now our I squared means a negative 1. You'll never write an I squared as a final answer. So the negative 14 and the positive 14, negative 14 and negative 1 make a positive 14. So we bring over the positive 14 over here and we get an answer of negative 18 plus 64I. Okay, you go ahead and try this one. Take the 2 and the negative 4 to make negative 8. 2 and the negative 5I to make negative 10I. Negative 4I. Negative 5I squared. So the negative 5 and the negative 1, because that's what an I squared is, it makes it negative 1. I squared is a negative 1. So that becomes a positive 5, which gives us a negative 3 when you combine those together. And your negative 14I. Now when we're dividing complex numbers, you should multiply both the numerator and the denominator by the conjugate. By the conjugate of the denominator. Recall that the conjugate of A plus BI is A minus BI. You got to change the sign so when you do the FOIL, those middle terms cross out. So here we are. We have a denominator that has an I in it. We can't leave the I down there. Because it has the minus in there, we're going to look at the conjugate. So we use 5 plus I. But we have to do that to the top terms too. So you think about multiplying these together. So 3 times 5 is 15. 3 times I is 3I, 20I, plus 4i squared. 25 plus 5i minus 5i minus I squared. That leaves us with 15 plus 23i, but here we're going to have the 4 times negative 1 because that's an I squared. Here the 5 i's cross out. That's the whole point of the conjugate. They're going to cross out. And that leaves us with a 25 minus a negative 1. So we can write our final answer. This is a negative 4. So we have 11 plus 23i over, this is a positive, so we get 26. Now the correct way to write these complex fractions is to write the real numbers and then the imaginary number. We need to write them separated. So you have your real number, which is your A, and then your imaginary BI. So what's the conjugate that we're going to work with here? One plus 4i. We do that to the top part of the fraction, the numerator, and to the denominator. So 7 times 1 is 7, plus 28i, minus 5i, plus 20i squared. We're just foiling this through, multiplying two binomials together. 1 times 1 is 1. 1 times 4 is 4i. Negative 4i times 1 is negative. So when we multiply by the conjugate, these have to cross out. That's the point of multiplying by it. So now we have the 7. Looks like 33i. Plus 20 times negative 1. 1 minus 16 times 1. That's going to give us a negative 20, so a negative 13 plus 33i. And a positive 16 and 1 is 17, so we write the 17 under each term. You have your real number and your imaginary number. So we're going to multiply by 1 minus I to the bottom and to the top because that's the conjugate. This is a little bit simpler. We got 5 minus 5i. 1 times 1 is 1. The outer, the inner, and the last. So a negative and a positive are going to cross each other out. Here we get 1 minus a negative 1 because I squared is a negative 1. So 1 plus 1 is 2. So we need to write that is 5 over 2 minus 5i over 2. Last one. What are we going to do with this one? (3i). Really, you only have to multiply by the I. You don't have to do 3i. I to the bottom and I to the top. So we're going to multiply that to both of those. So this is going to give us negative 2i minus 5 times negative 1 and 3 times negative 1. This becomes a positive 5. We put our real numbers first, our imaginary numbers second, and 3 times a negative. And we write that at the bottom. This is not a 26. This is a 2i. Put your real numbers together and your imaginary number. Now let me show you real quick what would have happened if we would have multiplied by the 3i. Most of you probably would have thought about multiplying by 3i. Here we would have gotten negative 6 minus 15i squared and 9i squared. That would have given us negative 6, well that would have been negative 6i. Negative 6i minus 15 times negative 1 over 9 times negative 1. Well, that makes us 16 minus 6i, and over here it makes it a positive 9. Oh, that's not 16. This is multiplying, so that would have still been a 15, not a 16. It would have been negative 15 times a negative 1 is a positive 15. Now you notice that all these all have a factor of 3 in them. So I can factor the 3 out and get 5 minus 2i. And in the bottom I can factor a 3 out. So those 3's cross out. And my final answer matches what I had here. There'd be a minus. So this is still a minus. So we would have a negative 5 over 3. Can't see that. You'd have a negative 5 over 3 minus, and that minus would become a positive now, right? 2i over 3, because the two negatives would make a positive. Well, that's what we could have seen here with our final answer. That could have made a positive. So that was kind of good that I looked over that answer. So I'll call that our final answer. But either way we did it. Here we multiplied by the I, and I got the same answer as when I multiplied by 3i. Doing with the 3i, I had to simplify that extra I out of there.